Okay, well, welcome to the final section of Chapter 2. There's a lot of proofs in this this last section, so make sure you pay attention. We're going to cover a couple of very important theorems and their proofs in this section. So, and you'll also be tested on this section quite a bit. So, make sure you pay really close attention and study this section very thoroughly. So prove angle pair relationships. So our objective, students will be able to prove that the vertical angles are congruent. This is one of the most important theorems in this semester of geometry. We will use this theorem over and over and over again. You'll see it many times. So it's my goal that you'd have this theorem memorized and how to prove it memorized as well. So there's a good chance you'll see this on the test for Chapter 2. So anyhow, the essential question, what is the relationship between vertical angles, between two supplementary angles to the same angle, and between two angles that are complementary angles to the same angle? Okay, well, that all sounds a little bit confusing, but we'll actually study each one of these, their theorems, so we'll prove them also. So got quite a bit of work and quite a bit of proving going on in this section, so pay attention. Okay, so here's a new theorem. All right angles are congruent. Okay, that's because they all measure 90 degrees, and so they're all congruent. Okay, well, that one's like a no-brainer. Here's one of them that we just mentioned. Two angles are supplementary to the same angle, then they are congruent. Now there's another one just like this. It has to do with complementary angles. Okay. Well, let's just take a look at what they're saying, though. It's saying like if whoa, get this off of here. Oh, goodness, my pin not working right. Ugly. Okay, so let's try this again. So if two angles are supplementary to the same angle in this case is this case here, but they're supplementary. Okay, so let's say this angle is 125 degrees, okay, and it's supplementary with this angle over here, which would mean what? Well, it means then that angle 1, let's see, they both have to add up to be 180 together, right? Okay, so that would mean that this one is 65 degrees? No, 55 degrees. 55 degrees, okay? Well, guess what? If we look at these angles over here, okay, they're supplementary also. Well, we already know that this angle 2 is 125 degrees, and so that means then that this one must be 55 degrees also. And see, so what it turns out in this case is that this angle must be congruent to this angle over here. And that's what this theorem is saying. If two angles are supplementary to the same angle, okay, that's that angle in the middle, then they are congruent. Okay, so theorems are a lot easier to understand if you put some numbers in there. And now it seems very obvious, well, duh, these are equal, right? Well, the same idea is true with this theorem down here. Here's the same angle, okay, so if you take these two and they add up to be 90, and this angle here we know is 60 degrees, okay, well, that means that this angle over here is 30 degrees, okay. Well, if you look at these two and say that they add up to be 90, well, we know this angle is already 60, so that means this one's 30 degrees, okay. So very similar theorems. So I'm not going to say much more about those, so let's continue see what happens next. Alright, so now we're going to actually prove this. So basically, instead of using numbers, like I just used in my example, we need to just go ahead and write out the proof of this. Okay, so as I said with most proofs, it's a good idea to start off with the given. So we start off with the given. Okay, so and so what we're trying to do is prove that angles 1 and 3 are congruent. Okay, so I want to give you some hints on how to do a proof. So we have this diagram to work with, and I just worked with the previous one, and I showed you how you could add these angles. But here's an idea. You see this word right here? It's the word supplementary. Basically, it's a form of supplementary supplements. Well, I said in my previous lesson in 2.6 that whenever you have vocabulary words in your proof, there is a good chance that you can use that in your proof. So the very next line in my proof, I'm going to write line 2. I'm going to write down what this means. Well, what does it mean? If two angles are supplementary, it means their sum is 180. Oh, okay, so then what I can do then is say angle 1 plus angle 2 is equal to 180. Okay, and the reason I can do this is that's the definition of what this word means. This word means that they add up to be 180. So the reason for this is definition of supplementary, and I'm going to abbreviate supplementary angles like this, supplementary angles. Okay, definition of supplementary angles. Now, well, take a look here though. I have the same statement right here, so rather than write a whole new statement, I'm gonna include this in statement for number 2. Angle 3 plus angle 2 is equal to 180 also. Okay, and so that's going to be my reason for number 2, or that's going to be my statement for number 2, and there's the reason for both of them. Both of them are using the definition of supplementary because we use it twice. Okay, now let's keep in mind, what is it that I'm trying to prove? I'm trying to prove that angles 1 and 3 are congruent. Well, so here's the idea. I see angles 1 and 2, I see 3 and 2, and they're both equal to 180. So you might remember back when I did that little algebra thing when I said y is equal to y, right? What did I do? I then took that one equation and substituted in for here. I took the other equation and substituted in for here. Well, here's the deal. I have two things that are equal to 180. Okay? So what I'm going to do is take this one and put it right here. Angle 1 plus angle 2. Alright? Oh, let me just show you on the side what I'm going to do. I'm going to start out 180 is equal to 180. Okay? That's kind of what I'm doing. And what I'm going to do is I'm going to take this part right here and put it in right there. And then I'm going to take this part right here and put it on the other side. You see? That's what I'm going to do. So let me just back up now so I get these marks off the screen. Alright. And so that's what we're going to write here. Angle 3 plus angle 2. Now, I wonder if you recognize what this is called. Think about the theorems that you know. Think about the postulates that you know. I'll give you a little hint. This one is called, well, it starts with the letter T. And hopefully you've come up with the idea that's called the transitive property, because it is what the transitive property is. So let me just show you that framework, how it's set up, the transitive property. The transitive property says if A is equal to B and B is equal to C, then what can you say? Then A is equal to C, right? Well, so you could recognize this symbol because, or this setup, because there's a repeat of this variable twice. And see, so this setup here, what do you recognize this thing that's twice? Well, in this case, this B would be the 180. This part would be the B, okay? And this would be the B again. And then this part over here, that would represent this part here. This part would be the A, okay? And then this part, there's the B, and so that means this part over here must be the C. So what did we say? We said A is equal to C. Well, that part there is the A. This part over here is the C. Okay? So I know this takes a little practice, but whenever you see the transitive property, you want to recognize that setup. And there's the basic setup right here. It's going to come up, this setup here is going to come up a lot in this geometry class. And here's another example where it comes up. So let me back up now so my paper looks a little bit cleaner. And we'll clean up some of these statements. Okay. Anyhow, that's what we have here. We have the transitive property. So the reason for this transitive property. Now I might add that you could have said substitution as well. But this framework is really, transitive is the correct idea, because what you have is angles 1 and 2 here. So there's angles 1 and 2, right? And then you have 180 over here. Well, someone said that 180 is equal to angles 3 and 2, so you could think of it as substitution. All you do is substitute the 180 there, and you substitute it in that. So you could get by with substitution also. Substitution property. But I think it's more accurate to say it's the transitive property. Okay? So we'll add this or substitution property. Alright, well there's the proof of that theorem. That's theorem 2.4. Alright, we just proved this now. Alright, well now let's try this proof. Theorem 2.5. Okay. Well, the framework is very similar to what we had before. You'll notice the same setup. Okay. So, we start off with, I'm going to do it right up here, okay? We'll put the statements and the reasons right here, okay, like that. I'll just do them right here. So, line 1, line 2, line 1 is going to be like angle 1 and, well, let me back that up. Angle 1 and angle 3 are complementary. Okay, I'm going to abbreviate complementary, and then they're complementary angles. Okay, and then the other thing that was given, this is my given statement, is angle 3. Angle 3 and angle 5 are, you guys are used to texting, right? So are complementary angles. angles. Okay? And the reason that we could say that, number one, is that they were given to us. Okay, so here's a common idea again. Whenever you have like a vocabulary word, there's a good chance you can use that in your proof. So line 2 is going to be, what does it mean to be complementary? Well, if you don't know, look in the back of the book and find out what complementary angles are. Okay, hopefully now that you've done that, you realize what they are. They're two angles that add up to be 90 degrees. So what that means, this statement becomes, well, angle 1 plus angle 3 is equal to 90 degrees. Okay? And at the same time, we could say angle 3 and angle 5 is equal to 90 degrees. Okay? And both of those are the same reason. We're going to call this reason number 2, definition of, move this now, definition of complementary angles. Okay? Alright, so there's line 2. Alright? And hopefully you recognize the setup again. It looks like, you know, if A is equal to B and B is equal to C, then what can we say? We could say A is equal to C. Alright, so let's see if we recognize what part is what. This part, I'll give you a hint. It's the part that's equal. That's this part, okay? Alright, so this part here is the B. This part's the B, okay? Now, what we can then say is this part right here. See if you can do this statement on your own, okay? Really try. Stop the video right now and see if you can write out this whole statement, this portion of the statement. We can do that. And what we're going to say, the reason for the step is the transitive property. Transitive property. Okay, hopefully this is what you came up with. This portion right here is the A, so you're going to write this as angle 1 plus angle 2 is equal to this part here is the C. This part is the C. So angle 3 plus angle 5. Oh, by the way, this is angle 3 here. Alright, now you'll notice what we're trying to do is prove that angles 1 and 5 are equal. Well, there's 1 and 5, and it looks like if we got rid of the 3, we would be done. So the next step, and this is going to look a little bit messy, but all I'm going to do is subtract angle 3 here and subtract angle 3 here. Now remember, when we write proofs, we don't normally write the algebra in here in the problem. So now write this as line 4. Angle 1 is equal to angle 5, and the reason I can do this is this statement here. Look what I did. I have an equal sign right there, and so what am I allowed to do? I'm allowed to subtract the same number on both sides of an equal sign, and that's simply called, well, it's line 4, that's called subtraction property of equality. Okay? Subtraction property of equality. And there we are, we're done. And you'll notice this proof was very similar to the previous proof. So let's review some of the steps. Okay, so you use this idea of complementary angles. What does that definition mean? And then you use the transitive property, and then you subtract off. So that turned out hopefully pretty easy. Hopefully you become more confident about how proofs work. Alright, so this one says linear pair postulate. If two angles form a linear pair, they are supplementary. Okay, so postulate means It's a rule that we're going to just accept. Theorems, on the other hand, are rules that we could actually prove. So we're not going to take the time to prove this. But basically, if you have a linear pair, okay, and you have angle 1 here and angle 2, it basically says that they're supplementary. What does supplementary mean? It says angle 1 plus angle 2 is equal to 180. Okay, so anytime you have a linear pair, we're going to have a couple angles. Angle 1 plus angle 2 is equal to 180. So in our proofs, this will give us the opportunity to write an equation. Okay, anytime you have a linear pair, it basically means you're going to write a statement like that. Okay, well, we also have a new theorem, and this theorem is, like I said earlier, it's one of the most important theorems in this whole first semester. And what does it say? It says vertical angles are congruent. Well, let me draw that on the diagram here. What does it mean if vertical angles are congruent? Well, angles 1 and 3 are vertical. They're vertical angles, so it means that, hey, well, those two are congruent. It also means that their measure of their angles will be equal. So in other words, if this one's 36 degrees, then this one has to be 36 degrees. Okay? There's another pair of vertical angles in here. That's 2 and 4. 2 and 4 are vertical angles as well. So those two angles are congruent. Okay? So please make sure you memorize this theorem. It's pretty easy. It says vertical angles are congruent. But the other thing you want to be able to memorize is the proof of this theorem. So that's what we're going to look at next, is how do we prove this theorem. So there's the basic picture. 5 and 7 are vertical angles here. Our job is to prove that they're congruent. Okay, so now you might say, well, hey, we just had a theorem that says that they're congruent. So they are congruent by theorem 2.6. Well, we can't use that yet because that's the theorem itself. So we can't use the theorem itself to prove itself. So we have to prove vertical angles are congruent without this theorem because we're trying to prove it for the first time. Alright, but like I said before, well, here's a vocabulary word, and this time we don't really use a vocabulary word, but let's use the diagram to see what we have here. Notice what we have here. We have a linear pair. We have a linear pair right here. And we were just told by theorem 2.5, or excuse me, not theorem 2.5, it was that postulate. We were just told on the previous slide that linear pairs are supplementary. So that means that they add up to be 180 degrees. Well, guess what? We have another linear pair going right here. And so we know from that last postulate that those also add up to be 180 degrees. Well, do you recognize this? We're going to have two equations with 180 degrees. That sounds like the transitive setup, where you have A is equal to B, B is equal to C, and then what are we going to say? We're going to say A is equal to C. A is equal to C. So that's that transitive setup. And you can almost see how to do this proof. Now we just have to figure out how to write it all out. So how do we write this? Well, first thing we can do is that linear pair idea. Since we have a straight line here and we have an adjacent angle here, we can say Okay, so line 2, we're going to say angles 5 and angle 6 form a, well, that's bad. Form a linear pair. Alright, now I will just say that angles 6 and 7 also do the same thing. And angles 6 and angle 7. Okay, these both form a linear pair. Now, the reason why I know that is because there's a straight line here in our diagram. So, all we're using so far is the definition of linear pair. Okay, well, now that we have a linear pair, we can use that postulate, the linear pair postulate. The linear pair postulate says that linear pairs are supplementary. So we're going to continue down here. So line 3, angle 5 plus angle 6 is equal to 180 degrees. And at the same time, we could say angle 6 plus angle 7 is equal to 180 degrees. And the reason why we can do that is because someone told me that we had linear pairs. And that previous slide told me that linear pairs are supplementary. Supplementary means that they add up to be 180. So this is the linear pair postulate. Alright, well, so now you should recognize the transitive property again. Let me just write that down. It said something like A is equal to B, B is equal to C, and therefore what can we say? We could then say that A is equal to C. Okay? And so here's the pattern. Where do you see the things that are equal? These are the two things that are equal. So in this setup here, this would be your B. This would be your B. Now, what we want to say then, or identify, where's the A at and where's the C at? Okay? Because we want to say that they're equal. So we're going to put an equal sign here, and the A goes here and the C goes here. But in this setup here, where's the A and the C? Alright, well, symbolically, this portion right here, this entire portion, is the A. Okay? So we're going to put angle 5 plus angle 6. And this entire portion right here, this portion, is the C, you see? And so that is going to go right here. Angle 6 plus angle 7. Alright, now I'm just going to erase things or try to clean things up a little bit. Well, hopefully you could recognize the transitive property there. We just did this setup here again. So the reason that I can do this, though, this step 4, is the transitive property. The transitive property. So there you have it. Well, now what are we trying to do? We're trying to prove that angles 5 and 7 are congruent. Well, there's angle 5, there's angle 7. And you'll notice this one, I have that one in there twice. Do you see? I have that one in there twice. So why can't I just subtract off angle 6? Well, that is indeed what we do next. We subtract off angle 6. So my next line is going to say angle 5 is equal to angle 7. Okay? And all I'm going to do is subtract off angle 6. So the reason for this step here, let's see. We can use our shortcut method. Subtraction property of equality. And the reason I can do that is because I had an equal sign. If I have an equal sign, I could add, subtract, multiply, or divide the same number on both sides of an equal sign. So there you have it. There's the proof of the vertical angles theorem. And we have just proven that vertical angles are congruent. Now, please understand, this is such an important theorem. And the proof is very important. I want you to be able to do this proof on your own on the day that we have the test in Chapter 2, which will actually be very soon, because Section 2.7 is the last section of this chapter. So, I would copy this proof and I would work it out over and over and over again until you have it memorized. Okay, so now they did it a slightly different way. You're welcome if you want to work it out this way. They're using the idea of linear pair again, and then they use the linear pair. Well, I set up the equations right here instead. Alright, and so then they use that theorem that we had before, which you can do also if you want. It said if two angles are supplementary to the same angle, remember the same angle in this case is that one right here. 5 is supplementary to it and 7 is supplementary to it, so that means they're both congruent. So this is a slightly shorter way to do it, so you're welcome to do the proof this way. I did an extra step here. So, well, there you have it. Make sure you study this proof, or you can study mine. Well, here's the deal now. We'll have several little problems where we use the vertical angles idea. And we'll also use the idea of linear pairs. Now, one thing you should realize is that this diagram is used over and over again for each one of these problems. So, what you'll do is use this information, and then you'll erase it, and then do a new problem with this new piece of information. So let's see here. If we're told that angle 1 is 112 degrees, well, we need to find out what these other angles are, 2, 3, and 4. Well, I know angle 3 is 112 also. Why? Well, because we just proved that vertical angles are congruent. Well, I think I can figure out angle 2 because they form a linear pair, and linear pairs are always supplementary. So I just need to figure out what number do I add to 112 to get 180 degrees. I need 180 degrees. Well, it looks like I'm going to need what? 60. How about 68? This one's going to be 68 degrees. And now I can get angle 4 easily because that's a vertical angle with angle 2. So angles 2 and 4 must be congruent, so that one must be 68 degrees. Alright? So there you have it. We did number 3. Now I'm just going to say that numbers 4 and 5 are the same sort of problem. But what you do is you erase your information and you start all over again. So let's take a look. If we do number 2, angle 2 is 67 degrees. Alright, well then that means angle 4 is 67 degrees. Alright, because they're vertical angles. We can figure out what angle 1 is because it's supplementary. So we're thinking 180. All we need to do is subtract off the 67 degrees, and then we'll have this angle down here. And I think it's going to be 113. Okay, 113 degrees. Well, that means this angle over here is 113 because it's a vertical angle with angle 1. And so we just did numbers 3 and 4. Now I'm going to waste our time to do number 5. It's the same sort of problem. But you'll have some of these on your study guide. You'll have some of them on your homework. And so you want to be able to do this fairly quickly. Alright, so what is the relationship between vertical angles and two... Well, there you have it. Vertical angles are congruent. Supplements of the same angle or congruent angles are congruent, and complements of the same angle are congruent. And there you have it. We did lesson 2.6, or excuse me, 2.7.